Shall we get started to stay on time?
Let's do it.
Yeah.
Okay,
Sure
great. So
thing.
welcome everyone. Welcome to the last day of Alife. We're going to start off with Demyan Vakhrameev's talk on measuring autonomy for lifelike AI. Demyan, the floor is all yours.
Okay, you can see everything well, right?
Yes.
All right, sick. Okay, so my name is Demyan Vakhrameev. I'm starting a PhD in Zaragoza University, and this work has been done with help of my colleagues and supervisor, Xavier Barandiaran and Miguel Aguilera. So artificial intelligence has of late is becoming more and more lifelike, which begs the question, how autonomous is it? If you're not very familiar with the topic of autonomy, here's a short briefing. So historically, some authors that worked in this area are Kant, Goethe, Ashby, Piaget, Varela, and some others. The subject of autonomy is usually associated with themes such as agency, identity, independence from and control over the environment and self, and sometimes responsibility and freedom of choice. And some of the more prominent modern authors who work in the field are Ezequiel Di Paolo, Xavier Barandiaran, Alvaro Moreno, Randall Beer, Tom Froese, just to name a few. And if I missed anybody important, I'm sure you will correct me, and please feel free to. But not to dwell too long on the introductions, the goal of our current work is to attempt to measure the autonomy of the said emerging lifelike AI. And to do the measuring, right, we need to do two things. So first, we need to set some axes along which to set some axes along which we can measure the dimensions. Measure the autonomy, and then propose the measures which will be used to measure it. Okay, so in modern literature, autonomy is usually divided into two categories. So this is kind of the standard view, right? The constitutive autonomy, which includes notions such as autopoiesis and operational closure, identity, reducibility, so kind of to do with agent dynamics itself. And the interactive autonomy, which refers to navigating and interacting with the environment, and this is sensory motor coupling of the agent and the environment, so kind of the agent environment dynamics. All right, and below are a few relevant works on the subject. Yeah, so that set status quo. But while this is a pretty solid ground, we would like to introduce some adjustments to this picture. And to do that, we rely on Margaret Bowden's intuition as a sort of as a basis for classifying three different types of autonomy. So she proposes the following three categories. The first is the extent to which response to the environment is direct or indirect, so determined only by the present state of the external world or mediated by inner mechanisms partly dependent on the creature's previous history. The second is the extent to which the controlling mechanisms were self-generated rather than externally imposed, so kind of like autopoiesis, basically. And the third is the extent to which any inner directing mechanisms can be reflected upon and or selectively modified in light of general interests or the particularities of the current problem in the environmental context. Yeah, so after reshuffling Bowden's suggestions and intuitions a little, we arrive at the following three dimensions of autonomy. So dimension 0 is self-generation, which kind of includes processes which are responsible for building the system to which they belong. Dimension 1, self-organization, includes processes which are responsible for the system's behavior. And dimension 2 includes processes which relate to the coupling between the agent and the environment, so the interactive dimension. So there are some examples, as you can see. The numbering might seem to you a little odd, but there is motivation behind this. So self-generational, self-making is the most fundamental type of autonomy, thus it gets the 0th number, very computer scientist of us. And it's also currently outside of the scope of our research, so kind of put it under the rug a little bit. I'm sure we'll come back to it eventually. Here the graph basically demonstrates how these dimensions, how we see these dimensions fit into the standard picture that I presented earlier. Okay, yeah. So focusing on the two behavioral dimensions, sort of 1 and 2, we'll present the graph, which ideally we would like to eventually populate with AI algorithms and I suppose AL algorithms as well. And here's some examples. So, for example, you, a strong, independent human being, have robust organizational and interactional autonomy. That's thus you're really high up there, in the top right. A puppet, on the other hand, is an inanimate object whose actions are completely and trivially determined by the environment and basically the physics. It has no internal workings at all. So its score is basically 0. You being brain scanned and manipulated, while you retain your consciousness and identity in this case, your control over yourself and the environment is completely undermined. So you're still a functional human being, but you can't do anything. So you're basically there is no control being attributed to you at all. So your dimension 2 is 0. Basically 0. And on the other hand, there's a feed-forward neural network, such as an Atari AI controller, like that plays Atari games. Due to it being a feed-forward network, it has no identity and exhibits no self-referential properties. However, it is capable of interacting with the environment in a highly competent way, sometimes better than people. So we give it pretty high self-control and environmental control, but low self-organization. Breitenberg vehicles are a potential example of high dimension 2 and low dimension 1. However, it's not entirely clear whether the sensory motor dynamics of the robot's body should be considered as contributing to its integrity and unity. So that's to be explored. And if you have any more examples, I'm curious to hear about them. And if you have any examples that don't fit into this view or breakout pitch, I'm also curious to hear about them. Please tell us about it. Okay, so those that basically covers the dimensions of autonomy as we see them. And now we move on to the actual measures of autonomy. Note that the references that corresponding to the works, the references mentioned correspond to the works where authors applied these measures to in the context of autonomy rather than the works where the mathematics were originally invented, right? So first is integrated information by Autonomy and Nozomi. There's a paper by Marshall where they apply IIT to measure autonomy of yeast. So that's kind of our first candidate for this, for dimension 1 really. And information closure developed originally by Berchinger and later by Chang deals with the agent-environment interactions instead of ascribing control to agent of the environment. This is our second candidate. But also some of the other promising measures of autonomy are geoautonomy, based on gradual causality by Tononi and Seth, empowerment proposed by Polanyi, and free energy, I'm sure you're aware of, proposed by Friston, Clark, and sort of applied to autonomy by Kibberstein. Yeah, so understanding and implementing these measures is still a work in progress for us. So this is sort of a shopping list at this point. So we're open to more suggestions if you have any. To go a bit more deeply on the measures, dimension 1, self-organization, we basically propose to use the integrated information theory. And quoting Aguilera and DiPaolo, integrated information is defined as the information possessed by a system which is above and beyond the information that is available from the sum of its parts, right? So practically speaking, the method is a little bit like dissecting frogs. The integrated information phi of the system is calculated by observing how a system moves from state st to state st plus 1, then partitioning the system into 2 parts, observing how the system behaves then, and then comparing the two. All right, so given all the possible partitions of a chosen system, phi is the minimum possible distance between probability distributions of a partition and the non-partition system. Basically, this means that if phi is high, no matter how you cut the system apart, there will be a significant change in its behavior. There'll be a significant change in its behavior. So the system is strongly integrated. And the distance measure used by Ozumi and Tononi in this case is Earth movers distance. although there's a variety that's employed in the literature. Know that there are many different definitions of integrated information that can be found in literature, and you can ask me or my colleagues in chat about this if you're curious. And as an alternative measure for this dimension, we propose gradual causality. Dimension 2, our proposed measure is Bertshinger's non-trivial information closure. So this measure tries to address the control dynamics in the agent-environment coupling. So when a process is taking place in the agent-environment coupling, who is in control of it, if anyone? The agent environment, perhaps it's a cooperation of sorts, right? So quoting Bertschinger himself, this quantity, NTIC, is maximized when the information flow into the system is minimal, but the mutual information between the system and the environment are maximal. So basically it measures the extent to which the system models its environment. So that attribution of control to any party can be pretty tricky, especially since mutual information is a symmetric measure, but I'm not gonna have too much time to go into the details here. I'm sure we can talk about it later if you want. And our proposed alternative for this dimension is empowerment, proposed by Polanyi and his colleagues. Right. So to wrap this up, here's some discussion and some questions that we had and our editors had. Why do we break down the constitutive dimension into self-generation and self-organization? Well, basically, we believe that it's not necessary for a system to create itself to exhibit properties that we'd like to call autonomous. So not only autopoietic systems should be called autonomous. Does dimension 2 reduce to dimension 1? So does the interactive autonomy reduce to behavioral autonomy? Not quite. In Randy Beer's talk on Wednesday, he demonstrated an example where the game of life glider's interaction graphs were isomorphic to its constitutive graph. So following this idea, it seems reasonable to suppose that all of the agent's behavior can potentially be explained by its internal processes. But as Randy pointed out, the agent's internal processes make only half of the agent environment coupling, right? So since our goal in this case is to measure interactive autonomy of the system, in this case, the environment is as crucial as the agent itself. So it's not about the agent or the environment, it's about their interaction basically. So even if the agent's potential behavior can be reduced to its internal processes, its interactive autonomy cannot. So I think this is demonstrated by the feed-forward network example. Is it possible to score high on the interactive dimension and low on the organizational one? So it's kind of similar question to the previous one. I think yes. So according to a paper by Oizumi and Tononi, the IIT 3.0, it's possible to make a finite feed-forward system that will temporarily simulate actions of integrated systems, so autonomous one, while not being integrated itself. So this means that while scoring very low in dimension 1, or 0 in fact, as a feed-forward network, the system should score high in dimension 2 because it can interact with the environment in a sophisticated way, at least for a finite period of time. Right, so why did we choose the measures that we did? Basically, these are the measures that we're currently familiar with. We're looking to explore more in the future. And there's a paper by Oizumi from 2016, reference down there, where the authors propose a unification measure of information geometry, which we're also interested to explore in the future. Are there more dimensions of autonomy than the three you proposed? Potentially, we're not sure. We'll find out along the way, I suppose. And some of the future directions of the research. We're looking to sort of measure more algorithms of AI and AL and put them on our graph that you saw earlier. We're looking to explore alternative measures. We're looking to consider some unification potential, and also there's always the problem of scaling. Just basically, most of these measures scale pretty badly because of computational complexity. Here are our acknowledgements. Thank you very much. That's me.
Thank you very much, Demyan. So I think we have time for one quick question. Martin, if you wanted to unmute yourself and ask your question. Martin, are you there? Maybe
Do you
not.
hear me now?
Yes.
Oh, okay. Yeah, I think Xavier already answered it. But yeah, what about measures for dimension 0? Which, in my opinion, is the most interesting question.
That is, I mean, that's totally fair. I feel like probably Xavier knows more about this. I'm looking for his answer in the chat frantically. To be fair, I'm not entirely sure myself. That's definitely outside of my competence currently.
Yeah, Xavier's answer was that you're not treating it, so.
Yeah, I mean, for sure, it's definitely something very interesting, especially for an Alife conference. But I think we're going to start easy, you know.
Yeah.
Yeah, fair enough. Fair enough.
Great. Thank you.